All right, this is just going to be a quick review of a few problems that I'll make up for you as far as ray tracing is concerned and the lens equation, or excuse me, the mirror equation. So, oops, I don't want to do that. I'll move this up. All right, so if I gave you a question like, let's say the focal length, and let's do a concave mirror first, was 20 centimeters. And an object was placed, let's do one of the more difficult ones, at 10 centimeters. So inside the focal length. What happens? What's the image distance? What's the magnification? What are the sort of characteristics of this? And there's, like I said, there's two ways to do this. Let's do the math one first and see if that makes our lives any easier when we actually go to do the drawing. Hopefully, if we do everything right, it will be obvious. So 1 over f is equal to 1 over do plus 1 over di. The first thing that we have to recognize is I said convex, which is a diverging mirror. That means this is negative. You will not always be told that in a problem. You have to figure that out. So 1 over 20 centimeters equals 1 over 10 centimeters plus 1 over di. If I pick common denominators, 2 over 20, subtract that over, I get negative 3 over 20, which when I solve for di means I get negative 20 thirds, or negative 6 2/3 centimeters. So that first thing there, that negative, should give us an idea that we have something interesting going on. So I'll put my answers in red. Negative 6 2/3 centimeters. Magnification, if we write that out, you remember it's negative di over do. So I'll just leave it as negative 20 thirds divided by my object distance was 10, which is negative 2/3. Okay, so what does that mean? I don't know why I switched to red. Negative 2/3 times. What does that mean? The negative means inverted. The 2/3 means smaller. And the negative also means it's behind the mirror, so this is a virtual image. Now, we'd like to do this with a drawing and see if it makes sense also. So here's your principal axis, and we'll put our mirror, we said convex, so I gotta bend it this way. The focal length is negative 20, so let me undo that one and I'll draw it. I'll try and draw it right there. We go. Right on that. So if each of these boxes is 5, we could go 5, 10, 15. There's negative 20. And my object distance was 10, so 1, 2, so 10 there. And what we would draw is some kind of an arrow. I'll do an orange arrow. And we'll make it 2 boxes tall. All right. The first line that I'm going to draw, and I guess I'll pick different blues and greens, maybe here's green, is if I go in parallel, it's going to reflect off through the focal length. So you have to kind of imagine it reflecting like that. That's the first one. Second one, I'll use purple for it. This one's always easy. If you go right to the middle here, and I may have skipped this the first time I went through, it reflects back. Oh, that was awful. I have a scale here. I should use it. It reflects back like that. So what you're seeing there, I mean, right off the bat, is they are diverging, which if they diverge, you want to trace the ray back. And I'll just do one more. What color should I pick here? This bluish. For this one, I'm going to have to add, for the third one, I'm going to add my center of curvature. If I went through, oh, that's awful. This is so hard to do. You know, I want to be able to trace this to this point out here. And if I did that, it should bounce off parallel. Actually, that's wrong. Let me undo that. I have that backwards. If I went through the focal point, it would bounce off. Oh, that's parallel, by the way. And again, all three of these are diverging. So what I do is I bring that one back, and I end up with that, which is a good thing I drew this because it just made me realize I made a mistake. So is this upright or inverted? It's upright, which means I screwed up math here because my answer was -20 and I took the negative of not -20. I left that. So this should have been positive. So this should have been positive. I wish I could say I made this mistake on purpose. Of course I did. I made this mistake on purpose. So there you go. There's an answer that actually makes sense and probably just convinced you that maybe doing a sketch is a good idea because I caught my math error. Again, the whole point of doing it was I made that mistake on purpose. All right, I'm going to stop there.